Hi and welcome to this video. In the last video, we have learned about different kinds of subsetting in Pandas: position-based, label-based, and value-based. In this video, we will particularly focus on one kind of subsetting, that is position-based. Now, first of all, I'm going to import Pandas, and we will read the same dataset, big part dataset, that we have seen before. So this dataset has 8,523 rows and 12 columns. So the first thing that comes into picture when you're talking about position-based subsetting is how can you access top or bottom end rows of your dataset. So head function is something that we have seen earlier. So let me just revise it for you. The head function lets you see first n rows of your dataset. If you pass a number here, like I have passed 10, here, so you'll get the first 10 rows. If you pass any number, for example 5, then you are going to get first 5 rows. Similarly, we have another function in Pandas, which is the tail function. So the tail function lets you see bottom n rows of the data frame. Similar to head, in tail, if you do not pass anything, the default outcome is you'll get the bottom 5 rows. If you pass a number, then you'll actually get those number of rows. Like here, I passed 2, and if you run this, you will get bottom 2 rows. So the head and the tail functions, they work based on the position of rows, that is the positional index that we have here. And that's why whenever you give it any value here, it will always get you the top 10 or the bottom 10 rows of the dataset, irrespective of what is your index. And this is something that we have already learned in the previous videos. So I hope you remember that. And so this was head and tail. The next question that comes to my mind is how you can access rows in a particular range using the position index. So first of all, again, this is our data frame. Here you can see. And we know that we have 8,523 rows and 12 columns. Suppose you want to access the rows based on their position in a particular range. For example, I want to access rows from 10 to 14. So I'm going to type here 10 to 15. And let's run this one. And I'll just use the syntax and I'll get the rows 10, 11, 12, 13, and 14. Now this syntax is very familiar to the list slicing syntax that we have seen earlier. So I hope you remember this syntax. Use a square bracket, use colon, and you give a starting index, which is 10, and then ending index 15. And ending index is always excluded. So when you say 10 to 15, Python will return from 10 to 14. Similar to the list, you can give a step size here. So let's give a step size of 1, and then run this. And you can change the step size to 2, and rerun this code. Now it skips one row, so 10, 12, and 14. Similarly, you can use also negative indexing. So let's type it here, negative 10, and keep the ending row blank. So minus 10 means starting from the last row, go 10 steps back. So if I say minus 10, I'll get the last 10 rows. So these are the last 10 rows of our data frame. So you can pass any index here, and you will get those values. And you can use all kinds of step values to make sure that you are able to slice through the data frame. Now, when it comes to the slicing through the data frame using positional index, we have another utility known as iloc. So iloc is essentially, as you already know, deals with position-based indexing. So suppose my next question is, how can you select particular rows by position? So now I'm not worried about getting the rows in a range, but rather what I'm worried about is I want specific rows, such as row number 1, 5, 2, 4, 6, and 14. This is something you can easily achieve using the iloc utility. So this is the syntax of iloc. So iloc is not a function, but it's essentially an attribute of the data frame itself. So you use two square brackets here, and inside that you can pass the rows like here and separated by comma. Let's run this. So if you run this piece of code, you will notice that all the rows that we have received from this query are actually the ones that we asked for. 1, 5, 2, 4, 6, and 14. Now iloc is a very useful utility in Pandas because apart from rows, you can also use it to get specific columns of your data using the positional index. So you know this item identifier has a position index of 0, item weight is 1, item fed content is 2, and so on. So suppose, say I want rows 1, 4, 5, 2, and columns 1, 3, and 5. You can rerun this code. So as expected, you have row 1, 4, 5, and 2, and we have the columns 1, 3, and 5. So column number 1 is item weight, column number 3 is item visibility, and column number 5 is item MRP. So this is the kind of advanced subsetting that you can do using the ilog utility. Now the good thing about ilog is you can use ilog to do the same kind of data frame slicing that we are doing using the square brackets here. So suppose you want a range of rows 10 to 15. You can just use ilog to do that, and the same negative indexing and same step size. All of the things that we were doing using just the square brackets you can do using ilog. Apart from that, you can also access particular columns using their index and particular rows using their index. So ilog is kind of a utility built on top of this. So you can use ilog to do the position-based subsetting in Pandas. Now we are going to learn more about different kinds of subsetting in Pandas and other attributes like ilog in the next couple of videos. So without waiting much, let's go to the next video. Thank you.